Okay, today we're developing our understanding of vectors. Continue to develop our understanding of vectors. So if v is a vector and the magnitude or length of that vector is 1, we always call that a unit vector. So the principal unit vectors are, if we're talking about the x direction, it will just be positive 1 in the x direction, so we're going to call that the unit vector I. If we're talking about the y, we're talking about up 1 in the y direction, that's going to be the unit vector j. So they're just saying here, hey, if we think about our vectors, how we wrote them last time, they could be written as in our components of just how far x and how far y they are going. So let's look at this first example. So I give you an initial and a terminal point. So we start here at negative 3, 1, and we end at 5, 2. And we want to think about the vector in terms of I and j. I'm going to start and just do what we did last time. So tell me how much right or left we're going from negative 3 to 5, we're adding 8. To go from 1 to 2, we're adding 1. And they're just saying, hey, that's the same as saying 8i plus 1j. This is an equivalent format. So now on this next one, let's do some operations. And just like we did last time, the way that we do these operations is we combine the i's, like the x components, and we combine the y's, or the j components here, right? So if we wanted to think about I plus v minus w, I may actually start over here and just do v minus w. So to do v minus w, you can think about doing negative 2i, and we're subtracting the 4i, right? So that gives us negative 6i for the first component. And then if I think about the other part is that negative 3j, and we're subtracting a negative j. So that's really going to be like adding it, right? So we'll get a negative 2j. So what are we now doing with that? And I'm just following order of operations. That's why I started with parentheses. We're now taking u, which is I, plus 5j. And if it helps you can totally rewrite it with the i's together. Or you could just say, okay, and then my v minus w is minus 6i minus 2j. Now we could say, hey, we're really just adding our like terms. So we get negative 5i. And then 5j minus 2j is plus 3j. So this would be the resulting vector. On this one, we're going to do 4 times v. So we're going to do 4 times negative 2i minus 3j. And we're going to do plus 2 times u, which is I plus 5j. So let's distribute the 4. We get negative 8i minus 12j. Distribute the 2, we get 2i plus 10j. Add your i's together, and we have a total of negative 6i. Add your j's together, and we have a total of minus 2j. Okay, so now let's talk about the unit vector. Some steps for the unit vector, if you want to think about it, is first find the magnitude. So if we find the length of the vector, then what we can do is divide, or I would say divide each component by the magnitude. And that will give us the resulting unit vector. So in this case, remember the unit vector is just saying, hey, the magnitude will be 1. So if I divide each component by the length, then all of a sudden if our length is 10 and we're dividing it by 10, we're going to get a length of 1. So here, the magnitude of A is equivalent to the square root of 3 squared plus 4 squared. So we get the square root of 9 plus 16, which is the square root of 25. So we get the magnitude is 5. So what we're saying to do here is take each of those components. So if we want to think about the unit vector A, then we're going to take 3i and divide it by 5, so I'll have 3/5 I, plus 4 divided by 5j. So this is our unit vector. Okay. And if you wanted to double check that, you could totally do like, hey, what is 3/5 squared plus 4/5 squared. And when you take the square root, we should get 1, right? The length of that vector should now be 1, which it is. And that's what we're saying, hey, it's a unit vector, has a length of 1. This one, not quite as pretty, but we can do it. So let's first find the magnitude of this vector b. So square root of -1/3 squared plus 5/2 squared. Here, I would probably just do that on your calculator. Like, you do get 1/9 plus 25/4, come up common denominator. Your calculator definitely can help you out here. We end up getting the square root of 229 over 36. Square root of 229 probably isn't the nicest. Actually, it's prime, so it's not going to break. It doesn't have any pairs of factors here, so it's not going to break down. So, and we're going to divide it by the square root of 36, which is 6. So in this case, the thing that makes this one a little bit harder, our unit vector b, we're going to take -1/3 I, and we're really dividing by the square root of 229 over 6. And remember, dividing by that is the same as multiplying by its reciprocal, right? I think sometimes that makes it a little easier to see. But we will also do the same thing with the j component of 5/2 j. We're going to divide by the square root of 229 over 6. So think about that as multiplying by the reciprocal. Okay, here we got a 3 and a 6. That would become a 2 on the top. So we would get -2 over the square root of 229i. You can rationalize the denominator, you don't have to. The 2 and the 6 would become 3. So we got 5 times 3 on top, so we get 15 over the square root of 229j. That is our unit vector. So it has a length of 1. Okay. But now let's remind ourselves, I think these next two examples are pretty similar to what you did last time. So we're going to do some operations, and they want you to make sure that you understand what the difference between a vector and a scalar is. So if we are adding vector v plus vector w, 3i plus 4j, and we're adding vector w, which is -2j, so plus -2, we'd end up with 3i plus 2j. The fact that we have those x and y components, not just a single number, this is a vector. Okay, on this next one though, when it asks you to find the magnitude of that quantity, right, we're now doing the square root. In this case, our x value is at 3, and our y value is at 2. So we've got the square root of 9 plus 4. So we get the square root of 13 as our answer here. And this one, in this case, is actually a scalar, right? It's a single number. It doesn't have direction anymore. It is just length. This last one's kind of an interesting combination. Here we want to find the magnitude of vector w. So the magnitude of vector w, in this case, w is just -2 squared, so the square root of 4 is simply 2. So we're going to then do 2 times vector v, which in this case is 3i plus 4j. So we will end up with 6i plus 8j. So even though we had a scalar out front, since we multiplied that scalar by a vector, this is a vector, right? It has components, it has a direction. And I definitely accidentally wrote j twice, so let's change that to an I real quick. 6i plus 8j. Right, if it has the direction along with the length, then it's a vector. Remember, scalar is just a length. Okay, let's look at the next one. Similar to what we did last time, right, if we have this vector, v, and it wants us to find the magnitude, in this case, the magnitude of v is, in this case, we've got a direction of 1 squared plus also 1 squared, so we get square root of 2. And then they want us to find the angle. So think about the tangent inverse, right? Our theta will equal tan inverse of 1 over 1. So we get tangent inverse of 1 is pi fourths, and that is in the right quadrant because we're in the first quadrant right now. So they're saying, hey, our vector v can be rewritten as the square root of 2 times cosine of pi fourths I plus sine of pi fourths I. So square root of 2. And then in this case, this is going to be square root of 2 over 2I plus square root of 2 over 2j. Sorry, I wrote that as another j. That should be an I, as it should be j. Now distribute your 2. The square root of 2 times the square root of 2 over 2. That's simply 2 over 2, which is equal to 1. So this vector resulting is going to just be 1I plus j. So it was not necessarily to approximate here, but it may be in the problem you're given on your homework. Okay, last but not least, I've got an application problem, and this one I did a little bit different. There definitely are still some with your directions, you know, you're going bearing south, 8 degrees west, etc. But I think you've seen a lot of those, so this one maybe has a little bit more of like a physics application. So it says a 50-pound speaker is suspended from the ceiling by 2 support braces. One of them makes a 60-degree angle, you can see that over here on the right, with the ceiling, the other makes the 30, right, on the left. What are the tensions of each of the supports? So here, we're basically looking for, this is going to be supporting it this way. So you can think about this as like tension 1. And then this one will be supporting it this way. You can think about this as like tension 2. So if we're looking for the tensions of those, we're looking for the length, so the magnitude. So here, we're really seeking out the magnitude of tension 1 and tension 2. Okay, I'm going to call these just x and y to make life a little easier. You do not have to, but you got to understand a little physics here, that, okay, I've got tension 1, I'm pulling on it, and I've got tension 2, but then technically this weight is pulling it down. So we've got this weight, this vector weight, pulling it down. And those 3 things are keeping it in the same position, so keeping it at 0, right? It's not falling, etc. So let's talk about some of these vectors. I'm going to replace this. We're going to call this vector x plus y plus w equals 0. Okay. I'm going to do some work over here on the left, and then we'll kind of bring it back. So vector x, in this case, we have to think about the direction. This angle down here could also be 60. So remember we said, hey, if we take the magnitude of x, we can rewrite that as cosine, in this case, of 60, and then also sine of 60. We learned that last time. So we could rewrite this as vector the magnitude of x, cosine of 60 is times a half, sine of 60, magnitude of x, times sine of 60 is square root of 3 over 2. So we can think about this first vector here as the vector of the magnitude of x over 2, comma the magnitude of x, square roots of 3 over 2. Okay. Our vector y, similarly, we could do the magnitude of y, but this time, be careful, this is 30 degrees down here, but since that's with the negative x-axis, we're really going a total of 150. So this is going to be cosine of 150, sine of 150. So if we distribute it through, we'd get the magnitude of y. Cosine of 150 now is negative square root of 3 over 2. Magnitude of y times sine of 150 is a half. So here we'd have plus the negative magnitude of y, square root of 3 over 2, comma, magnitude of y over 2. Okay, vector w, the nice thing about that is it's not going right or left at all, so we just got 0, and it's pulling down its weight, so we've just got a negative 50. So here we add 0, comma, negative 50, and this all equals 0. So if we wanted to kind of combine things, we can add the first components of each of these. So in this case, we'd have the magnitude of x, halves, plus the negative magnitude of y, square root of 3. Since these are both halves, let's just put it all over 2. Same thing, we can now add the second components to each of these. So magnitude of x, square root of 3, plus y, that's all over 2, but we also have this minus 50. And this equals 0. So what we get here is we actually get that this first component, right, magnitude of x minus magnitude of y square root of 3 over 2 equals 0. And we get this second component, right? Because if it equals 0, that's really 0, 0. Equals magnitude of x square root of 3 plus magnitude of y all over 2 minus 50 equals 0 as well. So we basically have a system. We've got x and y we're trying to solve for. So I'm going to solve this left one and substitute it in there because it doesn't look like, I mean, you can multiply everything by 2 and do like a system, but we got the square root of 3 that maybe is confusing. So I think I can substitute pretty easy here. So we'd have the magnitude of x minus the magnitude of y square root of 3 equals 0. So now let's subtract the magnitude of y square root of 3 to the other side. So we get that x, the magnitude of x, is equal to y, magnitude of y squared root of 3. At this stage, I'm going to plug that into this other equation. So the magnitude of y will now replace that. Square root of 3 times the square root of 3 is going to be 3 plus the magnitude of y all over 2 minus 50 equals 0. So we'd have 4 magnitude of y over 2. That just gives you 2 magnitude of y minus 50 equals 0. I'm going to add 50 to the other side, so running out of room here, sorry. 2 magnitudes of y equals 50. Divide by 2, the magnitude of y equals 25. So we know this tension 2 is equal to 25. Okay, now to figure out the other tension, the magnitude of x, we said, is the magnitude of y, which is 25, square root of 3. So, hey, that makes it easy to write the tension of 1 is 25 square root of 3. And you finished the problem. Yay! Good luck with the assignment.